Hello everyone. So today's topic of the lecture is predictive parsing. Here we'll see how the predictive parser works. The parser needs a stack, it needs the input string, and depending upon the stack, input, and the parsing table, it will generate the output. So parser checks the topmost element on the stack and the current input string or a current input character from the input string. Depending upon the topmost terminal or a symbol on the stack and the current input symbol, the parser identifies the action in the parsing table, and depending upon that, it generates the output. LL1 is a special form of predictive parser. So now we will see how the LL1 parser works. So here LL1, in this, the first L, it stands for the parsing of the input string. The parsing of the input string is from left to right, and that is the reason this first L indicates. This is what the first L indicates. The second L, it means there is a leftmost derivation. That is, we are expanding the grammar from the leftmost terminal, from the leftmost non-terminal. And the parenthesis, we have some number. So this number tells about the look aheads. If there are two look aheads, then here it will be 2. If there is one look ahead, it means there will be 1. Likewise, you can, depending upon how many look aheads you have, you can specify the number here. Usually, we are taking only one look ahead, and that is the reason here we have constant 1. Now, following are the requirements of the LL1 parser. Uh, the grammar for the LL1 must not have left recursion. It must be left factor. We need to compute the first and follow. Depending upon the first and follow, we need to compute the parsing table, and we need a stack implementation. Then the input string we will need, and we will need the parse tree, or we'll generate the parse tree. Now we'll see why we need to compute the first and follow. First and follow help us to avoid or to remove the backtracking. It helps us to pick the particular production. Now how it helps, that I'll explain now. Now see here why we need to compute the first. Consider the production. Here we have S produces C, A, D, and another production is A produces BC or A produces A, and the input string is CAD. Now we have to expand this S and A in such a way so that we should get this input string CAD. As the start symbol is S, we will start expansion from this, and S get expanded to CAD. So later the A will get expanded either to the BC or to the A, right? Now because the parser knows that when we will expand this S to the CAD, you can see the first symbol is C here, and first symbol of the input string is also C. So here it is matching. So later we need to expand A either to the BC or to the A so that it should match with the next input string. So parser knows the next input string is small a. So the first will help parser to pick the production A produces small a and ignore the production A produces BC. So here the first helps to pick the particular alternative, either particular alternative from BC or A, and it will help to remove the backtracking. Then consider the case why we need to compute the follow. If we have a production, A produces A, B, B, and B produces either B or epsilon, and we have an input string as a AB, so we need to expand this to get the input string AB. Now, after expanding A to A, B, B, the next is a non-terminal B. So, non-terminal B, it will get expanded either to the C or to the epsilon. But the next input character is small b, and the non-terminal B has no production that is starting with B. So what is following B is the small b, and because there is no production that is starting with small b, the B will get expanded to epsilon. So here, because we know what is following the B, or because depending upon what symbol is following the B, the follow helps the parser to pick the production B produces epsilon. Now we'll see the rules to compute first and follow. So rules to compute the first. Uh, the first rule is, if x is a terminal, then first of x is also x. If x produces small a, then the first of x is a. If x produces epsilon, then first of x is epsilon. And now here, I'll repeat this. For a terminal, the first is the terminal itself. If the production is x produces some terminal, then the first of x will be that terminal. If x produces epsilon, then the epsilon will be in its first. Now consider another production where x produces a or epsilon. So in this case, the first of x is both a and epsilon. If we'll consider this, if here we have a string, if here this a produces some string, the first alternative produces some string, then what is the first symbol of that string that we have to identify, and that if it is a terminal, then that is the part that is a part of first of that non-terminal. Then if the non-terminal is producing multiple alternatives, consider here, if here we have another string, then we have to identify what is the first symbol of that string or the second alternative. If the second alternative, it also starting with some terminal, then that terminal also get added to the first of x. I'll repeat this again. If here x produces a or a x produces epsilon, if we consider this, instead of a, here if we have the string, this is the first alternative, and here it is producing another string, this is another alternative, then identify the first symbol of both the alternatives. Identify the first symbol of both the alternatives. If both the alternatives has first symbol as a terminal, then add those both terminals in the first of x. Understood?
Yes.
Okay. Now consider another production. If x produces a. Now here you will say, here it is a non-terminal. So the first symbol of this alternative is not a terminal, it is a non-terminal. Then in this case, what we will do? See the production of A. Now A produces BC. Again here, the first symbol is not a terminal. Here it is non-terminal. But A produces epsilon. That is another production or another alternative. So A produces epsilon. So this epsilon can be placed here. A can get expanded to epsilon, and that is the reason the first of x will be epsilon. Now if we'll consider B, the first symbol of the first alternative of A, because it is a non-terminal, we'll need to see the production of B. Production of B is first is D alternative, and another alternative, it is starting with the left parenthesis, and both the alternatives are starting, the first symbol of both the alternatives are terminal, that is your D and the opening parenthesis, and that is the reason in the first of x we have this D, we have this opening parenthesis, and we have this epsilon. So if you'll see, if it is a non-terminal, if any production, the first symbol of the right hand side of any production is non-terminal, then we have to see the first of that non-terminal. If the first of that non-terminal is again another non-terminal, then we'll need to see the its production, and it goes on till we'll get the terminal, and that terminal will be added in the first of this non-terminal X. Is that clear to all?
Yes.
Yes.
Okay, so shall I proceed?
Yes.
All right. Now see this production. E produces TE dash, E dash produces plus TE dash or epsilon. T produces FT dash, T dash produces star F, T dash or epsilon. F produces opening parenthesis, E closing parenthesis or ID. Now if you'll see, this grammar does not have left recursion, and it is also left factor there. So this grammar we can use to compute first. Now to compute first of all the, we have to compute the first for all the non-terminals given in the grammar. So we will start with E. We'll compute the first of E. Now whatever rules we have seen in the previous slide, that if E is a terminal, the first of E will be E only. If E produces some terminal, then the first of E will be that terminal. If E produces some non-terminal, then we will go to that non-terminal's production, right? So here E produces TE dash, where this T is a non-terminal. So what we will do, we need to check the production of T. We need to check the production of T. So production of T is FT dash. Again, here we have a non-terminal. So we need to see the production of F. Now, if you'll see here, the first symbol of this first alternative is the terminal, that is opening parenthesis. F is having another alternative, which is ID, and ID is also the terminal. So we'll see, again I'll repeat, the E produces T, so we'll see the production of T. T produces F, so we'll see the production of F. We are doing this till we will not get the terminal. Now, if we'll observe the production of F, the first alternative is opening parenthesis, E closing parenthesis. If you'll consider this string, you will find the first symbol of this alternative is opening parenthesis. If you'll observe the second alternative, you'll see it is also terminal, and that is the reason the first of E will be
Left parenthesis.
yes, opening parenthesis and ID.
ID.
Now another next non-terminal, E dash. So the production for E dash is plus T E dash or epsilon. Now here we have one string or first alternative, and we have another alternative. Now what is the first symbol of the first alternative? What is the first symbol of first alternative for E dash?
Plus.
Plus. So is it a terminal?
Yes.
So can we add that plus in first of E dash?
Yes.
Right. Now another alternative is what? E dash produces epsilon. So if A dash produces epsilon, so we need to add that epsilon also in the first of E dash. So what will be the first of E dash in that case?
Plus and epsilon.
Plus and epsilon, right. Now same for next non-terminal T. So T produces Ft dash. So what we should do now? Is the first symbol of T is a terminal?
No.
No.
Then what it is? It is
It's
non-terminal.
a non-terminal.
Non-terminal.
So what we will do next?
We
If
will
it
see
is
the
not a
production of.
terminal, yes, Gaurav,
We will see the production of that non-terminal.
we will see the production of F, right? Now, what is the first, now F having again two alternatives. So we'll see the first alternative. What is the first symbol in the first alternative?
Left parenthesis.
Left parenthesis. Is it a terminal or a non-terminal?
Terminal.
Terminal.
So we will add the left parenthesis in the first of T. Can we?
Yes.
Yes.
Okay. Now, what is the another alternative of F?
ID.
ID.
Is it a terminal, non-terminal?
Terminal.
Terminal.
Terminal. So we will add ID in the first of T, right?
Yes.
Yes. Now consider if here we have some non-terminal, let's say instead of ID, if we have some non-terminal, say capital A, right? Here we have capital A and we have another production A produces something like this. So what you would have done to find the first of T? Instead of ID, if here we have a capital A,
Then we will move to the productions of A.
correct. Then we will add this left parenthesis, right, in the first of T, and also we will see the production of capital A to identify the capital A's first, right? Yes.
Yes.
Here we have the first string. Instead of ID, if we have here capital A, so the first symbol of the first alternative is a terminal. So we will add it in the first of T. But another alternative of A is starting with the non-terminal, no? So we'll need to see the
Yes.
production of that non-terminal. And the first of A is a terminal, then that terminal we will add in the first of T. Getting, no? It means you need to check
Yes.
all the alternatives. You have to apply all the rules, whether it is a terminal and non-terminal. If any of the alternatives is having non-terminal, you have to follow the next route so that you can go to that non-terminal's production. Right, no? Clear to all?
Yes, ma'am.
Yes. So now we will have now first of T dash. What will be the first of T dash? Applying all these rules.
Non-terminal. Terminal.
First of T dash will be
Terminal.
Star and epsilon.
star and epsilon. Right. And what will be the first of F?
Left parenthesis ID.
Left parenthesis and ID.
Left parenthesis. So this is clear to all?
Yes.
Yes, ma'am.
Yes.
Okay. So shall I proceed?
Yeah.
Yes.
Yeah.
Ma'am, one doubt.
Yes.
Ma'am, if F produces A and A produces nothing, then what will be the first of F?
If A produces nothing, it means A produces epsilon, no?
Epsilon.
If capital A is a part of the grammar, it means there must be some production for capital A, no?
Yes, ma'am.
If A is producing nothing, it means A is producing epsilon.
Okay, ma'am.
So at least that production will be there in the grammar. A produces epsilon. So in that case, epsilon will get added,
Okay, ma'am.
right?
Yes.
So shall I proceed now? Any
Yes.
other doubt so far? We have only 7 minutes left. So now see the rules for the follow. So follow always, you need to check to compute the follow, you always need to check the right portion of the production, right? You have to see the non-terminal uh, on the right hand side of the production. Now if X is the start symbol, then the follow of X is the dollar, and dollar is also the dollar is used to indicate the end of the input string. So your input string, it ends with the dollar, and if the X is a start symbol, then the follow of X is a dollar. If you remember in the stack, when I've explained the working of the predictive parser, that in the stack, the bottommost symbol was a dollar, and because it is a top down approach, the very first symbol from where we will start the expansion will be the root symbol or the start symbol. And so the first element or a symbol that will get pushed into the stack will be the start symbol, and below that start symbol was the dollar symbol, right? And that is the reason follow of the start symbol is dollar. Clear
Yes.
or not?
Yes.
Okay, let me, here if you'll see, below X you will find the dollar, right? And because it is a top down approach, our expansion will start always with the start symbol. Top down approach, yes. So we'll start deriving the string from the topmost or a start symbol.
Yes.
Yes, so start symbol we will push first, that will be the first symbol that get pushed into the stack. So what is following the start symbol is the dollar, no? Right? What is coming after X, or what is coming after this start symbol, is the dollar.
Yes.
So what is following start symbol is the dollar, right? And that is the reason in case of follow, the if X is the start symbol, the follow of X is the dollar. Then why it is dollar is mentioned here as a end of the input string, and the dollar as a follow of the start symbol. This I'll tell when I'll explain the stack implementation, right? What is the significance why your input string is ending with the dollar sign. Now if we have the production like this, A produces BA. So what is the symbol or a symbol, what symbol is coming after non-terminal B?
Small a.
It is small a, which is a terminal, right? And that is the reason the follow of B is a small a. Now if you'll see another production, A produces alpha, B, beta. Now if this beta, if I'll say, it can be the string, beta represents string, and if this string starts with some non-terminal, like here, A produces alpha, B, C, and then we'll see the C produces plus D. So here this C will get replaced with plus D, right?
Yes.
C will get replaced with plus D. So now what terminal is following B?
Plus D.
Plus D. So we will get the follow of B will be plus D. Now if this beta is epsilon, right? So we will get the production, right? A produces alpha B, right? Because beta is epsilon, or beta produces epsilon. In that case, what symbol following B? It is the follow of B in that case will be the follow of A, right? Or the follow of B is the follow of non-terminal, which is on the left hand side of the production. Clear to all? If it is a start symbol, the follow of the start symbol is dollar. If we have a production, A produces BA, then the follow of B will be the A. You always have to see the right hand side of the production. So if you want to find the follow of B, you have to search B on the right hand side of the production, and then you have to see the symbol which is following that non-terminal or a B. If the B, there is no symbol that is following that non-terminal, then the follow of that non-terminal is the follow of non-terminal which is on the left hand side of the production. If there is no symbol following non-terminal B, then the follow of non-terminal is the follow of A, right? So if we'll apply this rules, we'll see the follow of follow of E will be what? So search your E on the right hand side of the production where we have E. We have E here, right? We have E here. F produces,
Yes.
right? So what non-terminal following E? After E,
Right parenthesis.
what terminal you are getting? It is right parenthesis. Also, E is your start symbol. So the follow of E will be what? Follow of E will be what?
Parenthesis.
Right parenthesis and dollar.
Dollar.
Right? Now we'll see the follow of E dash. Now find the E dash on the left hand, on the right hand side of the production. We have E dash here. We have E dash here. There is nothing
Yes.
after E dash. So what will be the follow of E dash? It will be the follow of E. Right?
Yes.
Now search T on the right hand side. What we have? T is followed by E dash. Here also T is followed as E dash. So what we will do now? Follow of T will be what? The first of E dash? Follow of T.
Yes.
What will follow the T?
E dash.
E
E
dash.
dash.
So E dash में क्या है? इधर प्लस से स्टार्ट होने वाला या एप्सिलॉन?
Yes.
Plus
Right? And what else?
E. E का follow.
E ka follow. Why? Because there is nothing after E dash in the first production. E produces TE dash. Is it? We are finding the follow of T.